comes from one of the past papers, and it tells us in the diagram, O is the center of the circle. They tell us that ST is a tangent to the circle at T. The minute we read that, okay, that ST is a tangent to the circle at T, the word tangent is a key word for us, right? So we've got to start thinking about, why have they told us that ST is a tangent to the circle? How can we use the fact that it's a tangent to the circle to help us in our solution? So when we read the word tangent, we start thinking to ourselves, tan-chord theorem, or tangents from the same point, or radius perpendicular to tangent, etc., etc. Okay, so we've got to use that keyword and link it to all those reasons that we know. Right, T and M are points on the circle such that Tm equals MP. Okay, so they've given us two equal sides. OT, OP, and TM are drawn. Let O1 be equal to X. Prove with reasons that STM is equal to 1/4 of X for 7 marks. So this is quite a hectic question, isn't it? All right. Before we get started, I want to ask you guys a question. If you look at the diagram, is TMPO, so TMPO, is it a cyclic quad? Is TMPO a cyclic quad? Okay, good. All right. No, it's not. Okay. And we're not able to prove that it is, but it's not a cyclic quad because it doesn't have 4 points on the circle. Okay. So one of the points is in the center. So we cannot assume off the bat that it's a cyclic quad. All right, good. ST is a tangent to the circle. So if ST is a tangent to the circle, what angle is ST equal to? What is ST equal? If ST is a tangent to the circle, then T1 is the angle between the tangent, ST, and the chord, MT. So what angle does T1 equal? Not O1, unfortunately, can you see there? There we go. That's it, Aisha, P1. Okay, so can you see there? It's got to be the angle in the alternate segment. Okay, so it's P1. Okay, so ST is the tangent, TM is the chord, and TM subtends P1 at the circle. Can everybody see that? Chord MT subtends P1 at the circle, and angle T1 is the angle between the tangent ST and the chord MT. Is that okay? Can we see that? Okay, no problem. Can you see that? So straight away, we know that T1 equals P1 because of tan chord theorem. Okay, so what does P1 equal? Absolutely. What's the reason why? Can you see there? Why does P1 equal T2? You're quite right. What's the reason? Good. Yes, SL Bavuma. Angles opposite equal sides. Lovely. Good job. Very nice. Okay. So now we know the size. Well, we don't know the size, but we know that T1 equals P1. We know that P1 equals T2. Okay. Now we're trying to get to X. Okay, because we've got to prove that STM, in other words, T1, is 1/4 of X. So where are we going to go from here? We know that P1 and T2 are equal. where do we go next? Oh, makusandile. M equals 1/2 of x. Angle at center equals 2 times angle at circumference. Okay, but now hang on a second, all right? Because if we've got angle at center, you're on the right track, okay? If we've got angle at center is 2 times angle at circumference. Let's just draw this, okay? So now we need a center, all right? So if we have a line here and a line there and a line there and a line there, here is the angle at the center, and it is 2 times the angle at the circumference. Okay. So O1 is not the angle at the center. The angle at the center is actually O2. Can you all see that? Okay, so O2 is twice as big as M. Does that make sense to everybody? T1 plus T2 equals O2. No, I'm afraid, Colafella, that's not true. T1 plus T2 equals X. I'm afraid that's not true either. Okay, so angle O2, how big is it? How big is O2? You can only work in terms of X. Can anybody tell me how big O2 is in terms of X? There we go. Can you see there? 360 minus X. Good job. Now remember, the angle at the center, which in this case is 360 minus X, is twice as big as the angle at the circumference. Okay, so how big is the angle at the circumference? It's got to be 360 minus X all divided by 2. Doesn't it? Does that make sense to everybody? Okay. All right. So now we finally have correct, Makusandile. So 180 minus half X. Lovely. Okay, correct. Because 360 minus X all over 2, you're quite right, is 180 minus half X. Good. Isn't M equal to 90 degrees angle in a semicircle? No. Angle in a semicircle, an angle in a semicircle is created when you have a diameter. Okay, so you have to have the diameter subtending an angle at the circle to have angle in a semicircle. So it looks like this. Okay, so you've got your circle, right? You've got a diameter, and the diameter subtends a right angle at the circle. So this would be equal to 90. Okay, so you don't have a diameter in this case. Right, so that's why M is not equal to 90. Okay, does that make sense? Let's just hear you ask that question. Mbongeni, does that make sense? Yes, it does. Okay, all right, lovely. So now that we've had all these discussions, let's try and put something down onto paper, because remember, we've got to prove that T1 is 1/4 of X. Okay. What is Kanyisile saying? That 180 minus 1/2 X plus P1 plus, you mean T2? I think you mean T2 equals 180, Kanyisile? So if your second P2 is T2 equals 180, that's lovely. Yes, absolutely, because they are angles of a triangle. Quite right, and we are going to use that. Yes, 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 yes. Okay, so let's start putting things down on paper. We've kind of worked backwards from STM to O2. So let's start at O2 and work our way back to our answer. All right, so the first thing that we want to declare is that angle O2 is equal to 360 minus x. What is our reason for that? Why is O2 360 minus x? What's the reason there? Revolution, quite right. Angles around a point or revolution, good job. Excellent. So now that we've concluded that O2 is 360 minus x, now we can say something about m. M is equal to 360 minus x divided by 2 because of angle at center equals 2 times angle at circumference. Let's just rub this guy off. Okay, which means that m is equal to 180 minus 1/2 x. Okay. So now, Kanyisile said, if we add m and P1 and T2 together, we get 180 degrees because we've got a triangle. All right, so m plus P1 plus T2 is 360, listen to me, is 180. Okay, so m plus P1 plus T2 equals 180 degrees because of the angles of a triangle. So m, just going back and look in the picture, m plus P1 plus T2 is equal to 180. Okay, but remember P1 and T2 are equal to one another. Okay, P1 and M and P2 are equal to one another. All right, so what we've got here, let's just say that, but P1 equals T2. All right, and we were told earlier that the reason for that was because they are angles opposite equal sides. Sorry, I'm just going to move this one down a little bit. As always, I've never given myself enough room. Doesn't matter how much space I give myself, it's always never enough. Let's just move that right down there. Okay. So what we want to do is we want to work in terms of angle P1. Because remember, it's P1 that's equal to T1 because of tan chord theorem. So I want to express T2 in terms of P1. Does that make sense to everybody? So I'm now going to say angle M plus 2 of P1. Does that make sense to everyone? Okay. All right. So I'm just checking in with you guys. Thank you, Kanyisile. Thank you, Aisha. Thank you, Ayobakwe. And now we can go ahead and we can go and substitute. All right, because remember, M we said is 180 minus 1/2 x plus 2 of angle P1 is 180. So now we're going to take, because the 180 and the 180, that would add up to 0. And now we're going to take this minus 1/2 x over to the other side, isn't it? So now that's going to be equal to half x. Okay, and now I have to divide by 2 and divide by 2, and that means that P1 is equal to 1/4 of x. Everybody happy? We're nearly there. All right, and now we can say, but P1 equals STM. Okay, P1 equals STM because of tan chord theorem. So therefore, STM is 1/4 of x. All right. How do you feel? Does that make sense to everyone? Nice. Oh, good. I'm glad you feel nice. Good. Good, Kamisile. Good, Aisha. Good. Nice, Niliswa. Oh, sorry, Nilisiwe. And Pumeza. Good. Oh, good. I'm glad, Kwanele. Good, Tabile. All right. Nice. Mbogeni, you've raised a hand. You're welcome to unmute and speak. Do you want to ask something? Mbongeni, you're welcome to unmute and ask.
Oh, he said.
Oh, you pressed it by mistake. Oh, okay. All right. Okay, fine. Not a problem. All right. So in that case, let's go and have a look at our next question. Sorry, I'm going to just drag. Oh, come on. Give me hassles now, please. Just pull this guy down. And then we've got a bit more space here. All right. So I hope this is big enough. Let's see what we can do here, just about making that a bit bigger. And then maybe what we can do is put that over there, and then maybe just try and enlarge that a little bit as well. Okay. Let's just move that a smidgen up. Okie dokie. Right, so this is a little bit more of a difficult question. All right. I mean, the previous one was also, I suppose, problem solving. And here, not everything is going to be problem solving. Some things will be complex. But definitely when we get sort of down to the last thing, then that would be problem solving for us to have to figure out. Okay, so in the diagram, ST and VT are tangents. ST and VT are tangents. Okay, they're tangents from the same point. Okay, so tangents from the same point are equal to one another. So that's going to become important to us. R is a point on the circle, and W is a point on chord RS such that WT is parallel to RV. SV and WV are drawn. WT intersects SV at K. Let S2 be equal to X. All right, so everything that they've told us in the information is on the diagram. So remember, matrix, really important. Read the information first. Okay, think about why they have told you things are tangents or diameters or chords or whatever the case is, because those are clues to help you answer the questions. All right. So now they want us to write down with reasons 3 other angles, each equal to X. Okay, so I'm just going to move that down a little bit. Hopefully you guys can see that okay. All right, what else is equal to X in the diagram? Okay, so Kanyisile says R. Good, Kanyisile. And you're saying W3. Good, Kanyisile. Very good. V3. Yes. Yes, it is, Paul. Lovely. Well done. You guys are really good. That's excellent. Nice. Okay, so shall I let you do that on your own? All right, so write down 10.2.1, the three angles that are equal to X and your reasons why. I'll let you do that quickly. Indeed, SL Bavuma, there was more than one. Okay, so it's hard for you, you know, it's difficult online because you don't have the page in front of you and you can't move things around, okay? Remember, ST is a tangent. So if you've got a tangent, more than likely you've got tan chord theorem. So S2 is the angle between the tangent and the chord. The chord is ST, sorry, the tangent is ST, the chord is SV. So R is the angle in the alternate segment. Okay, so R is equal to X because of tan chord theorem. Okay, then the next one that Kanyisile mentioned was W3. So Essel Bavuma, can you tell me why is W3 equal to R? Why is W3 equal to R? Any idea?
Sorry, ma'am.
Yes, Cornelia.
Will only be W2.
Nope. It's W3.
Okay.
Okay, so she's quite right. It is W3. It's not W2. W2 is going to end up being equal to X as well, but it's not equal yet because we haven't proved that WSTV is a cyclic quad. But it will end up being equal to it as well, but you can't prove that at this stage.
Ma'am.
Thank you, ma'am.
Okay, no problem. Can you see there?
W3 is equal to X because of corresponding angles.
Oh, you well done, my darling. That's 100% correct. Okay, Kanyisile, quite right. Good spot. Okay, so here, Isel Bavuma, look here. This is what Kanyisile saw. Okay, there's the backbone, and here's your F. You see how they're corresponding angles? Okay, so this angle over here and that angle over there are corresponding. All right, lovely, Kanyisile. Well done. That was excellent. All right, so W3 equals X because of corresponding angles. And remember, when you use corresponding alternate or co-interior angles matrix, you have to name the parallel lines, okay? And they will be strict with you about that because you've been doing this since you've been in grade 8. Okay, so we have to name WT parallel to RV. I know, right? Yeah. And then the last one was one that somebody else mentioned. I think it was Aisha. Let me just go back and have a look. Aisha, no, I know you said W2. Oh, it was Makusandile and Mpo. Okay, Mpo and Makusandile, you were quite right. It would be V3. Okay, why? Mpo and Makusandile, why V3 is equal to X? What's the reason that V3 equals X?
Yes, tangents.
Okay, so yes, so we're just got to be careful here. ST equals TV because they are tangents from the same point. but S2 equals V3 because they are angles opposite equal sides. Okay, so this is the reason. Angles opposite equal sides. Yeah, tangents from the same point are equal. That proves that TS equals TV. Because TS equals TV, it means that V3 is equal to X because of angles opposite equal sides. Okay, which, you know what I should have done? I should actually put that in there. Hang on a second. If I'm being 100% accurate, let's just add that in. All right, so ST equals TV because they are tangents from the same point. And therefore, V3 equals S2 equals X. Because they are angles opposite equal sides. Okay, and now we are. Okay, so Isel Bavoo, I'm going to ask you a question now. Can you see it? Can V3 be equal to R because of tan chord theorem? Absolutely. Absolutely. Yeah, you could say that as well. Yeah, quite right. So V3 equals X, if you said tan chord theorem, that would also be perfectly correct. Yes, can you see it? Correct. Good, well done. You really are seeing the connections here. That's excellent. Okay, Isel Bavuma, are you all right? What you said, wait, how? Are you?
I understood the tan chord reason for S2 equal V3, but I don't understand the angles opposite equal side one.
Okay, so angles opposite equal sides, it's in a triangle. So here's your triangle. If ST equals TV, then these two angles over here have to be equal to one another because they're angles opposite equal sides.
Wait, did they say that?
They don't say that, but what they tell us is that ST and VT are tangents. So we know that TS equals TV because they are tangents from the same point. So that means they're equal in length. So because they're equal in length, it means that S2 and V3 are equal because they are angles opposite equal sides. That's what it means.
Okay.
Okay. All right, happy with that. Okie dokie. Yeah, can you see that you're on a roll? Well done, girl. All right, so there we go, our 3 reasons. Or if you wanted to here, like you said, Mr. Esel Bavuma, if we wanted to say that V3 was equal to R because of tan chord theorem, that would also be perfectly correct. So as an alternative to this, we could say that V3 equals R equals X because of tan chord theorem. Okay, so that would be an alternative. All right, if you want to. Okie dokes, let's go on to the next thing. What do they want us to do now? Prove that WSTV is a cyclic quad. So WSTV, so let's just clear some of this stuff for you. Okay, so that is this guy. WSTV is a cyclic quad. Prove that it is a cyclic quad. So remember what we've already got. We've got that this is X. We've got that this is X. And we've got that this is X. Can anybody see it? Why is it a cyclic quad? Okay, so there's a bow tie inside, isn't there? I can draw the circle, but you know what? It's not necessary for us to draw the circle. I mean, I can if you want me to, but whoopsie, there we go. But drawing the circle, oops, let's just see. Ew. Not the greatest circle. Okay, so when you're proving that something is a cyclic quad, you're proving that it's possible to draw a circle through, sorry, I mean, this might not be a perfect circle. Yeah, but you're proving that it's possible to draw a circle through the points, okay? Not that it necessarily exists, okay? So if you want to prove that a quad is cyclic, there are 3 ways that you can do it. What are the 3 ways, Matrix? Can you remember? 3 ways to prove that a quad is cyclic. Okay, yes, yes. Good boy, Chairpaul. Good, Nina. Good, Aisha. It's a very specific way of us saying these things, but you're on the right track. There we go. And Paul, converse of exterior angle. Yes, now you're using the right language. Okay, so let's just go down here and make a quick summary for you. Okay, so proving a quad is cyclic. Okay, so the first thing that you said, and Paul, was converse exterior angle of cyclic quad. Good. All right, what's the next one? Converse. Let's go back and see what. Angles in the same segment, Boyd share Paul. Okay, so converse angles in same segment. Converse angles in same segment. Good. Third one, I think Aisha said it, but I'm just going to go back and go and check. Yes, Pumeza, good. Check for an exterior angle. Okay, so that was that one. Aisha, was you. Check the opposite interior angles equal 180. So that is converse. Opposite angles of cyclic quad add up to 180. Okay, so converse exterior angles of cyclic quad are supplementary. Okay. That's it. Okay, so those are the 3 ways, and that's how you have to set it out. All right, is using these reasons exactly as I've written over here. So either converse exterior angle of cyclic quad, or converse angles in same segment, or converse exterior, converse opposite, it's not exterior, it's opposite. Beg your pardon, converse opposite angles of cyclic quad are supplementary. Yeah, sorry, I meant opposite. Yeah, sorry, Aisha, quite right. It should be opposite, not exterior. Converse opposite angles of a cyclic quad are supplementary. Okay, so my recommendation to you is that when they ask you to prove that a quad is cyclic, always see if you can do converse angles in the same segment first. So in other words, look at your cyclic quad and ask yourself, is there a bow tie inside? Right? So if you look at this cyclic quad, is there a bow tie inside? Yes, absolutely. Okay, so because there is a bow tie inside, it's highly likely that we're going to use converse angles in the same segment. Remember, geometry is a story. Okay, so 10.2.1 leads to 10.2.2. So the fact that you have written down 3 angles each equal to x is what is helping you in the next part of the story. So have a look at what you have proved is equal to x. Which 2 things are both equal to x? because of converse, and that proves that it's a cyclic quad because of converse angles in the same segment. Okay, so Paul, you are saying S2 equals W2. No, we don't know that W2 is equal to X yet. Okay, so Nina, when I'm talking about the bow tie inside, I mean this. I'm going to do it in pink for you, okay? There's your bow tie. Okay. That's the bow tie in pink. Does that make sense, Nina? So there's the bow tie. So I'm just going to rub all of that out again. But yeah, essentially, this is your bow tie here. Okay, so the bow tie does this. There's a crossover here, there, and there. That's your bow tie. Okay, and then it happens to be inside that quadrilateral. Okay. So what do we know is equal to X? Well, we know that S2 is X. We know that W3 is X. We know that V3 is X. And we know that R is equal to X. So inside the bow tie, now this is the part that I need you guys to see. Put your fingers, if possible, put your fingers at S and T. Now you're going to go from chord ST, you're going to follow to W3 and back to ST, and then from ST to V3. Okay, so fingers at S and T, follow SW and TW to W3, back to ST, and from ST to SV and TV. Okay, can you see there? They're both equal to X. W3 is X and V3 is X. That's converse angles in the same segment. Does that make sense to everybody? Right, can you see that now? Okay, so I always say, and I mean, again, you know, the limitations of us doing this online, I mean, if we could sort of turn it around this way and look at it, it might be a little bit more obvious. But ST is the chord that subtends W3 and V3. Okay, and because they are both equal to X, that proves that WSTV is a cyclic quad. Sure, Aisha. So what I was doing is this. Okay, let me rub the pink out again. Okay. So Aisha, let's write in a nice bright color. This is X and this is X. So your fingers are at S and at T. So now you're going to follow the lines to there. Take your fingers back to S and T, and then you're going to follow the lines to here. See your bow tie? So fingers at S and T, Aisha, and go from S and T to W, back to S and T, and from S and T to V3. Okay, because those two angles are equal to one another because they're both X, that proves that WSTV is a cyclic quad because of converse angles in the same segment. All right, so let's put that down on paper. All right, so we already have from 10.2.1 that W3 and V3 are X. Okay, so in 10 point, where are we? 10.2.2a, 10.2.2a, we can say W3 equals X and V3 equals X, proved above. Therefore, W3 equals V3. Therefore, WSTV, I think that's right, yes, is a cyclic quad. Converse angles in same segment. Okay, is that making sense to everybody? I'll just go down there if you want to write that down. Okay, so because W3 is X and V3 is X, they're equal to one another. So because they're equal to one another, WSTV is a cyclic quad because of converse angles in the same segment. Okay, so it was only out of 2, all right? So because it was only out of 2, that's why we knew that there was a hint for this, because there wasn't actually that much writing. So it's this over here, and then that reason over there. Okay, those would be our 2 marks in this case. Right. And now, remember earlier, there were a whole lot of you that were saying that W2 is equal to X. Well, now it is, because WSTV is now cyclic, so W2 will be equal to X because of angles in the same segment. Okay, which we may need. In fact, we do need, because we want to prove that WRV is isosceles. Okay, so proving that WRV is isosceles, that's this bit over here. So here's WRV, is this triangle over here. So what does it mean when they tell us to prove that a triangle is isosceles? What are they asking us to show? Correct. So Aisha, that's exactly it. All right. If it's not being given, you have to prove it before you can use it. Exactly. Okay, exactly. But now let's say, Aisha, that you were unable to prove that WSTV was a cyclic quad. All right. In order for you to access questions B, C, and D, you would then assume that the quad was cyclic, but you would lose out on those marks because you haven't been able to prove it. Okay, but yes, you are supposed to prove it before you use it. Okay, that's the whole idea. And once you've proved that it's true, and you don't have to prove it again. You see, that's why a lot of people don't like geometry, because you have to think. Okay, you can't just apply a formula. You're not just subbing into a formula. It forces you to think. Okay, and I know, absolutely, and that's all you can do is try. And you're doing very well. All of you are doing really well. Okay. And again, I mean, this is something that you're gonna, you almost there. It's what? It's September now. September, October, November. You're done. You've just got to hang in there. It's another 3 months and you're there. Okay. Look at what Nina is saying. Nina is saying that W2 is X and that V1 is X and then WRV is isosceles. Nina, quite right. Good. Okay, you are on fire as well. Good job. So Nina, tell us, why is V1 equal to X as well? Because they are, V1 and W2 are what sort of angles, Nina? There you go. Awesome. That's lovely, Nina. I'm so glad you were thinking about that while we were talking. That's brilliant. Okay. I hope that, yes, quite right, Kaiser. Oh, it's Tisha. Okay, it says Nina. I was actually wondering, like, we've never had a Nina before, but anyway. Okay, so it's you, Tisha. Well done. Okay, good. Good, 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 good. Okay, so hopefully the rest of you saw what Tisha did as well. Let's just get rid of this stuff over here and we can write that down. Whoopsie. That. Right. Okay, so Tisha, what were you telling us? You were telling us that W2, so here we are, 10.2.2b,
Sorry,
W2,
ma'am.
yes.
Ma'am, can I ask? Don't you
Of
have
course,
to
Cornelia.
don't you have to prove that W2 is a X already, or the previous question already proved it itself?
No, you've got to state now that W2 is equal to X. Now that you've proved that the quad is cyclic, now we can say that W2 is equal to X because of angles in the same segment.
Thank you, ma'am.
No problem. And then we're going to conclude that V1 is equal to X, as Tisha said, because they are alternate angles. And again, remember, you've got to name the parallel lines, okay? They're not going to be forgiving of you for forgetting the parallel lines because alternate and corresponding angles are from grade 8, okay, parallel to RV. Okay, so that's it. So now we've got an angle R is equal to X because we have proved this above in 10.2.1. Okay, so what's important here is that angle R equals angle V1, like Tisha said. I don't think so, Mr. Bavuma, but we'll have another look at it now. I don't think there's another way to do this. Therefore, triangle WRV is isosceles. Actually, no, hang on a second. Before we say that, we need to conclude, beg your pardon, just leaving things out here. Therefore, WR equals WV. Okay, therefore, triangle WRV is isosceles. Okay. Sides opposite equal angles. Okay.
Ma'am, can you please kindly go over the mark allocation for this question?
Yeah, with pleasure. Okay, so this was out of 4. Okay, so there has to be a mark on the reason. Okay, so the sides opposite equal angles. There has to be a mark on proving that those two sides are equal. And then here, I would say there would have to be a mark on proving that R and V1 are equal to one another. And I think there would probably be one mark on that as well. Okay, that would be my take on things. Okay, Cornelia.
Thank you, ma'am.
All right. Okay, let's do C. All right, so now they want us to prove the triangle WRV, which we have already highlighted in green. So let's highlight this in green, is similar to triangle TSV. So let's do TSV in yellow. So TSV is this triangle over here. All right, so how are we going to prove that the green triangle and the yellow triangle are similar to one another? Yes, can you see there?
Ma'am, wouldn't we just say that we already have the two angles? Therefore, the other angle, which is W1 and T2 plus T1, is a third angle of a triangle.
Quite right.
Therefore, the triangles are equal or similar.
Yeah, absolutely, Kanisile, you're quite right, because we've already proved that S2 is X and V3 is X, that R is X and V1 is X. So you're quite right. By virtue of the fact that the angles of a triangle add up to 180, W1 and T1 plus T2 have to be equal to one another. Okay, yes. Okay. All right. Michael Sandili, can we find W1? Yeah, absolutely. Absolutely. Quite right. Yeah, it's the third angle of a triangle. You're all correct. Lovely. Well done. Okay, so let's get this out the way and then we can set it out over here. Okay, so remember, when we prove similarity, we've got to set it out in the correct way. Okay, so in triangle WRV and triangle TSV, point number 1. Okay, so angle R is equal to angle S2, both equal X. Point 2, angle V1 is equal to angle V3, both equal X. And number 3, W1 must be equal to the whole of angle T, angles sum and triangle or remaining angles of a triangle. So therefore, triangle WRV is similar to triangle TSV, angle, angle, angle. Okay. I know the boys at my school also call things chai, so. Oh, goodness. You guys are very funny. Okay, so yes, there we go. So we've proved that these two triangles are now similar. And again, as I keep saying to you, geometry is a story, okay? So the fact that indeed they've asked us to prove that RV over SR equals KV over TS has probably got something to do with what we've just done. Okay, so yeah, expect that there are going to be connections.
Can I please run the poll right now?
Yes, go for it.
Yes. Okay, you're gonna see something pop on your screen. Please just answer it because we want to see how do you feel about the pace of this lesson.
Oh, you have to hide the suffering.
I must be too old because I've never heard of that word. It must be chai.
Yeah, I know. Even me. The boys at my school say it, so that's how come I've heard it. But yeah, I'm the same. Right. So one of the ways that you can answer this question, right, is when they ask you to prove a proportion, right? Remember, you look across or around the outside? Do you guys know what I'm talking about? So you ask yourselves in the beginning, is RVK a triangle? Okay, now if we have a look at the diagram, RVK is not a triangle, so let's try the outside. Is RVS a triangle? Yes, Tisha.
Ma'am, I was
Yes.
taught by my teacher that you use, like, if you just from proving triangles that are similar, you just use those angles that you got to prove the proportion.
Absolutely.
Proportion.
Absolutely. So there's two ways that you can do this question. You're quite right. So what you can do is you can work from here, all right, and then manipulate, or you can look at the proportion and you can say, in which triangles am I going to work? Okay, so there's two ways you can do it. You're quite right. Okay, so let's just finish this off. I don't know if we'll be able to do both ways, but let's just finish this off. Okay, so if you conclude that around here is a triangle and around here KV, but hang on, KVTS is not a triangle. KVT, no, that's not going to work. All right, let's write the corresponding sides that are, we're running out of time here. Let's write the corresponding sides that are in proportion. Okay, so that means that WR over TS equals RV over SV equals WV over TV. Okay, because they are the corresponding sides that are in proportion. Okay, so we want an RV, we want SR, which is not there, we want KV, which is not here, and we want TS, which is not here. So it looks as though we are working with this. All right, so let's just go down here and rub this bit out. Okay, so now we've got WR over TS equals RV over SV. But we don't want WR and we don't want SV. Okay, so is there anything that we can replace? WR VW KV. Okay, we've got parallel lines. Okay, so because we've got parallel lines, we're going to have to use proportionality intercept theorem as well. Okay, because SW over WR is the same as SK over KV. Can you guys see that? So proportionality intercept theorem in this triangle here, because of the, whoa, sherbet, because of the parallel lines. Oh my goodness. What is this thing doing? Silly thing. Okay, so what I'm getting at, just rub all of that off, okay, is remember this line here and that line there are parallel to one another. So we can apply proportionality intercept theorem in this blue triangle. Okay, so SW, so let's just write that down as well. So SW over WR is equal to SK over KV. Okay, because of proportionality intercept theorem, and that is because WK is parallel to RV. WK is parallel to RV. Okay, so what do we want? RV over SR. Okay, so if we've got RS, that's the whole side. SVTS. Yeah, you're looking at which triangles you're going to work in. I'm sorry, I'm just feeling a bit stressed out now because the lesson has ended and I just need a little bit more time to think about this. SR is that side over there. KV, because you see, if they're talking about RS and KV, then RS is this whole side over here. KV is this side over there. So let's try, if we try SR over SW, SR over SW is equal to SV no, hang on a second. I think it's SR over WR. SR over WR. SR over WR is SV over KV is SV over KV is SV over KV. Proportionality intercept theorem. What do we want? RV. Okay. Over SR. TS is the same as TV. Okay, so now the other thing that we've got to bear in mind is that TS equals TV because they were tangents from the same point. So that means we've got WR over TV equals RV over SV. RV SR. This is irritating, isn't it? There has to be a connection here. So R, TS, TS, and TV is R over SV. It's just also so difficult when you have to go up and down and up and down. RV over SR, RV over SR is equal to KV over TS. Yes, no, we are still doing grade 12 work. Don't stress, don't stress. Of course we are. So it's got to be something that we know. I mean, they're not asking us anything outside of our syllabus. So we're on the right track here. We've got RV. We don't have KV. SR, we have WR, we have SV. So that's the only one thing. Here we have SR. We don't want WR. Do we want SV and KV? What can we put?
Ma'am?
Yeah. Yes, Tisha.
Right, we proved that triangle WRV is similar to RVT.
Yes.
Isn't it, can't we say ST is equals to WV? Then we substitute the ST where there's WR.
Yes, so I think this is what we need to do. Okay, so we know, I'm just writing this on paper. So we know that we've got RV over SV equals WR over TS. Okay, because triangle WRV and STV were similar to one another. So what have we not tried? Let's try, if we cross multiply, what happens? So we've got WR times SV equals RV times TS. Then from proportionality intercept theorems, looking at this triangle, we've got WR over SR equals KV over SV. We could also cross multiply. Hang on 1 second. So that gives us WR times SV equals KV times SR. Therefore, RV times TS equals KV times SR, because SV and TS are equal to one another. So therefore, RV over SR equals KV over TS. Okay, let's do it. Let's do it. Okay. All right. So I'm just going to clear all of this off. We've got it. Okay. All right, so just to quickly finish this off. Sorry, guys, we've gone way over time here. This is a little bit of a tricky one. Okay. Okay, so from proving that the two triangles were similar to one another, so we can conclude that RV, now we know we want RV because we've got RV over there, okay? So RV over SV is going to be equal to WR over TS, okay? Because we want TS here as well. All right, so that comes from corresponding sides in proportion. So what this means for us, if we cross multiply, it means that WR times SV is RV times TS. I'm cross multiplying. Now, into this triangle, which I was saying to we could do proportionality intercept theorem. Okay, so WR, WR over SR, so in other words, WR over SR is going to be equal to KV over SV. It's going to be equal to kV over SV because of proportionality intercept theorem. And that is because we have our parallel lines, which in this case, WK parallel to RV. WK parallel to RV. Okay, so now when we cross multiply, we get WR times SV is equal to KV times SR. So can you see here, we've got a point of comparison. WR times SV and WR times SV. Okay, so if they're both equal to the same thing, what we can conclude now is that RV times TS is equal to KV times SR. And that means that RV over SR is equal to KV over TS. There we go. Okay, what a question. All right, but anyway, there we go. At least it's done. Okay, sorry guys. Yeah, anyway, well done everybody. I'm sorry it's a bit late now. We better say goodbye. Yes.
Ma'am, I think I speak for everyone, but this last question,
was killer, hey Cornelia? Absolutely. But you know what, Cornelia, if you have a look here, all right, and this is what's important, okay? The last question is not important. Can we do this? Yes. 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 All right. So what that means is that out of what's that, 7, 11, 13, okay, it's not 25 entirely because there was something else before this as well, but that's 8 and 4 is 12 and 12 and 7 is 19 marks, right? So out of 19 marks, we've got 8 plus 7 and that's 17. Am I going mad here? Hang on. 6 plus 2 plus 4 plus 3 is 15. Plus 4 is 19. Okay, so I was correct in the beginning. It's 19 marks. All right, out of 19 marks, we can do 8 plus 4 plus 3, which is 15. Okay, so out of 19 marks, we can do 15. 15 out of 19 as a percentage is 78.9%. So don't worry about question D, is what I'm trying to say. Okay. Sure, Johannes, I'll go back down again. Okay, so it started over there with the corresponding sides in proportion, then I cross multiplied, and I got what WR times SV was. Then I worked in the triangle, blue triangle, did proportionality intercept theorem. And again, I got WR times SV. Okay.